Good morning, guys. Good morning.
Morning, sir.
How are you?
Fine, thanks. And how are you, sir?
Fine. Who is this one? Joshua Oratile, Galaxy Club, and Jolisha. How are you?
Fine, and you, sir?
Fine. I'm sorry I didn't send in the work, but I'm gonna do it after this lesson here. I'll send it to you guys. The one on magnetic fields and magnetism. Yeah? Right. So last time we're talking about magnetism. So I'm just going to go over because there are a couple of pictures that I've added as well. So I'll just go over that quickly. So we're going to go over this. Then at the end, we'll go over we'll look at the corrections of that consolidation activity. Right, so here's the magnetic field around a bar magnet. So it goes like this, all right? Always moving from north to south. So north goes out, south it goes in. Please make sure your lines, they do not cross the magnetic field lines. All right, then poles of a magnet. I think this picture was not here. So you've got your north and your south, and they both attract objects. All right, then you've got your magnet. If you break it into half, then you're still gonna have your north and south, north and south, north and south. So you still have your poles there. So there's no monopole. So you still have your two poles. Then last time I think here there was a mistake here. Like poles, still there's a mistake here. I didn't correct this one, but it's fine here. I think I've added it here. Opposite poles attract, right? Opposite poles attract, and unlike like poles repel. So same poles repel, and opposite poles, they do attract, right? Then you've got your magnetic field lines, how to represent them. So that's what you have there, right? These are ion filings and they're magnets, so you're gonna have something like this, right? Then your magnetic field for poles that are repelling, this is what you're gonna have. So it can be north and north, they still repel because they are the same. South and south, they still repel. All right, so that's what you have there. For attraction, this is the magnetic field that you might get. You might have something like this without including the other ones happening on the south, but to complete everything, this is what you have, both on north and south, north, and the other ends of the magnet. This is the magnetic field that you're gonna have. Please just check here, they are still crossing here. When you do yours, they mustn't cross like this. On this picture, they are crossing, they mustn't on your diagrams when you are requested to draw one. Right, then we've got ferromagnetism. What is ferromagnetism? It is a phenomenon shown by materials like iron, nickel, and cobalt. These materials can form permanent magnets. They always magnetize so as to be attracted to a magnet, right? No matter which magnetic pole is brought towards the unmagnetized iron, nickel, or cobalt. So ferro, it's about attraction. And the ferromagnetic materials, there are three. It's iron, nickel, and cobalt. Those are the three that are ferromagnetic. Then you've got paramagnetic materials. These are materials like aluminum, platinum, which become magnetized in an external magnetic field in a similar way to ferromagnetic materials. However, they lose their magnetism when the external magnetic field is removed. This is just for your own information. You don't have to study this. Just it's not part of the syllabus. Syllabus only looks at ferromagnetism. Diamagnetism is shown by materials like copper, bismuth, I think plastic as well, which become magnetized in a magnetic field with a polarity opposite to the external field. Unlike iron, these ones, they do not get attracted. Instead, they are repelled by a magnet, right? So they are diamagnetic, right? That's what we mean by diamagnetic. Then we move on, right? We've got the compass. The compass is an instrument which is used to find the direction of magnetic field. So a compass, you're going to have your cardinal points, your north, south, east, and west. And you can still have other compasses with northwest, northeast, southwest, southeast. All right, so you've got the needle there, that is magnetic. So you've got a magnetized needle. And at the center, you've got a pin there, which is like the pivot where it rotates. Right, a compass consists of a small metal needle, which is magnetized itself and which is free to turn in any direction. Therefore, when in the presence of magnetic field, the needle is able to line up in the same direction as the field. So if you bring a magnet closer to a compass, then it's going to move and become aligned. Right, the direction of the compass arrow is the same as the direction of the magnetic field. So if you put it around a bar magnet, then your needles or your compass is going to align according to the magnetic field of that particular magnet. Right, compasses are mainly used in navigation to find direction on the earth. Right, this works because the earth itself has a magnetic field which is similar to that of the bar magnet. So the magnet on the compass, it's affected by the magnetic field of the earth. Basically, underground the earth, there are metallic elements. So there's like there's a magnetism which interacts with those with the one on the compass. Right, the compass needle aligns with the Earth's magnetic field direction and points north, south. Once you know where north is, you can figure out any other direction. Right, and some animals as well can detect magnetic fields, which helps them to orientate themselves and navigate. Right, so animals also, it's purported that there are animals that move. For example, if it's winter this side, they fly maybe to go to Europe where there's summer. But how do they find direction? It's postulated, or it's proposed that on their beaks, there's some magnetic field on their beak, which is able to give them direction, just like a compass, how a compass works. Right, so some animals can detect magnetic fields, which helps them orientate themselves and navigate. Animals which can do this include pigeons, bees, monarch butterflies, sea turtles, and certain fish. I think a couple of months or so, there were so many white butterflies that were moving. The other people were saying they were moving to Madagascar. How do they know the direction? So it means they should be using the magnetic field to move. Right, I think also people, they are doing pigeon racing. They take a pigeon, maybe they take it to Port Elizabeth or somewhere, then they release it. Then how does it find direction? It also uses that magnetic field. Right, so now we go back, we go to the earth. So the earth's magnetic field, which is very similar to the magnetic field of a giant bar magnet. So here in the earth, it's like there's a giant bar magnet underground. So if you bring a compass, then the compass is going to align itself according to this magnetic field here. It's going to align itself according to this magnetic field. Right. You've got your magnetic field around the earth as well. So anything that is on the surface of the earth will be affected by that if it's magnetic. Right? Then you've got your magnetic north. It's up there where that bar goes. Then you've got your south at the end, the magnetic south pole. Right? The earth has two magnetic poles, the north and the south pole, just like a bar magnet. Right? Then there are two poles that we have. We have got a magnetic north pole and we've got a geographic north pole. What is a geographic north pole? We know the earth rotates. When it rotates, that's when we get day and night. So it rotates on its axis, right? The point where that axis comes out, that's what we call the geographic north. Then for the magnet is also slightly bent about 11.5 degrees from the geographic north. So we're gonna have a bar magnet which is slightly tilted from the axis of the Earth. So there's that deviation of 11.5 degrees. So there's a couple of degrees difference between the magnetic north and the geographic north pole of the Earth.
So, but isn't the magnetic north changes all the time?
Yeah, yes, it moves. It moves, but it doesn't move that much. It moves a few centimeters per year, I think. So that angle might be changing, but it only changes by a fraction, right? Okay, right. Distinguishing between magnetic and geographic north. A compass is used to determine magnetic north. It does this by aligning its magnetic needle with the magnetic north. Geographic north is about 11 degrees east of the magnetic north, right? This notion of there being two north poles can also be a bit confusing. You need to understand which one we're talking about, geographic or magnetic, right? The Earth's magnetic field axis is inclined at about 11 degrees west of the spin of the spin axis of the Earth. The spin axis is the axis of rotation of the Earth, right? That gives us the day and night. The Earth rotates about the spin axis every 24 hours. The top of the spin axis is geographic north, and the bottom is the geographic south, right? North pole and south pole. The line of longitude that connects north and south is the one that is 0 degrees, which is the Greenwich meridian, right? So it's a longitude, lines of longitude, right? Then we move on. The magnetic axis shifts slightly over time. So that's the one that Joshua, you're talking about, right? Scientists monitor the position of the magnetic axis on a daily basis, even though it changes its position slowly over many decades and centuries, right? Almost every 200 years, there have been reversals of the magnetic field of the Earth. In fact, there's been no reversal of the magnetic field in the last 800 years. So perhaps we are due for this to happen soon. Very little is known about the effects of a reversal in the Earth's magnetic field. Some scientists believe a reversal of the magnetic field has been accompanied by extinctions in the past. So that reversal there, it might result maybe in extinction of some animals or something. A bar magnet has two poles. We have a north and a south. The poles are actually called north-seeking pole and south-seeking pole of the bar magnet. The north pole of the bar magnet seeks the north magnetic pole of the Earth. So basically, there's an interaction between the pole on the compass and the pole on the Earth. So they seek one another. So when you're using a compass, it seeks the north pole. The south pole of the bar magnet seeks the magnetic south of the Earth, right? The north pole of a bar magnet is being attracted to a south pole of another magnet. Therefore, the magnetic north pole of the Earth is actually a south pole. Because we know like poles, they repel. Unlike poles, they attract. So therefore, the magnetic north pole of the Earth is actually a south pole. Because the north pole of the compass is going to be attracted to the south pole. So the south that we say it's in the magnetic north, actually it's a south pole because the north of the compass seeks, it looks for the south pole of the Earth. Right, that's what the point is highlighting then. The lines of magnetic field are directed downwards at the magnetic north pole and upwards at the magnetic south pole, as you've seen in the diagram above. So here on this diagram here, right? So this actually is for the magnet, it's your south, right? Then that one is your north for the earth. But for the bar magnet that we use, or the compass, that will become the north, because north and south, they attract, and the south goes this way. So actually the north, geographic north, it's a south pole in terms of the magnetic field of the earth. Right, the South Pole, 6, that I think I've read that. Then we move on. The compass needle points to the magnetic North Pole, which is actually slightly different from the geographic north. So for you to find direction, you have to now add a couple of degrees for you to find the geographic north. Otherwise, the magnetic north will give you a slightly different directions. So people who are pilots, I think they take that factor into consideration. Otherwise, you end up going to Maputo instead of going to Joburg or something. You deviate because of that 11 degrees. So they have to factor in that difference between the magnetic and the geographic north. Clear? Right, then there's phenomena related to the Earth's magnetic field. The importance of the magnetic field of the to life on Earth. Why is magnetic field of the Earth important? The Earth's magnetic field is very important for humans and other animals on Earth because it protects us from being bombarded by high energy particles that are being sent by the sun. So the sun sends charged particles, protons, electrons, and so on, in the atoms that are sent, right? So the Earth protects us, the magnetic field of the Earth protects us from that. The stream of charged particles, mainly positively charged protons and negatively charged electrons, coming from the sun is called solar winds. So they are solar winds from the sun, right? When these charged particles come close to the Earth, they are deflected by the charge, by the Earth's magnetic field, and then cannot shower down to the surface where they can harm us or living organisms, right? Why? Because of the charged particles. So like charges, they repel, and unlike charges, they also, like charges, they repel, unlike charges, they attract. Astronauts in space are at risk of being irradiated by the solar wind because they are outside the zones where the charged particles are trapped. So they go away where there's no magnetic field, so they are bound to be affected by these solar winds here. The region above the Earth's atmosphere in which charged particles are affected, we have got Earth's magnet is called the magnetosphere. So the region above the Earth's atmosphere in which charged particles are affected by the Earth's magnetic field, we call it the magnetosphere. Relatively often, in addition to the usual solar wind, the sun may eject a large bubble of material, that is protons and electrons, with its own magnetic field from its outer atmosphere. It's also supposed that it's also postulated that the sun has got its own magnetic field. So there could be large bubbles of material because of the effect of that sun's magnetic field that are sent into the atmosphere as well. Sometimes these bubbles travel towards the Earth where their magnetic fields can join with the Earth's magnetic field. When this happens, there's a huge amount of energy that is released into the Earth's magnetosphere, causing what we call a geomagnetic storm. So the geomagnetic storms looks like that, all right? This magnetic field from the Earth and the other one from the sun, then they're gonna interfere there, all right? So those solar winds happens in space, outer space. And if some of them are to reach on the surface of the Earth, then it can cause problems and trouble here, right? These storms cause rapid changes in the Earth's magnetosphere, which in turn may affect electric and magnetic systems on the Earth, such as power grids, right? We have got the cell phone networks. and other electronic systems. Right. So I think I've been hearing people complaining there's a slowing down of networks and so on. It could be maybe some of these geomagnetic storms that will affect the communication. No one knows. Maybe it could be a possibility of that effect. Right. Then we've got what we call northern lights and the southern lights. We call them aurora. Another affected cause by Earth's magnetic field is the special northern and southern lights, which are also called aurora borealis and aurora australis, respectively. The borealis is the one that happens in the north, in Austria, somewhere there. Then aurora happens in Australia, in the southern hemisphere. The other one in the northern hemisphere of the Earth, and the other one in the southern hemisphere, right? When charged particles from the solar wind reach the Earth's magnetosphere, they spiral along the magnetic field lines towards the north and the south poles. If they collide with the particles in the Earth's atmosphere, they can cause a red or green light, which stretch across a large part of the sky and which is called aurora. Right. So these are some of the sightings that are seen certain periods of the year. These are the northern lights, so it becomes colorful in the atmosphere there, and there are so many colors, nice colors there, right? But unfortunately, us, we cannot see these ones. People who are closer, I think, to the poles are the ones who see this, right? Then aurora australis, I think people in Australia, they see this, right? These are the lights that they see for the southern lights. This is what they see. All of this is to do with magnetic fields, magnetic storms that happens in the atmosphere, right? As this only happens close to the north and south poles, we cannot see the aurora from South Africa. However, people living in the high northern latitudes in Canada, Sweden, Finland, for example, often see the northern lights, maybe in winter or summer, depending. So this is what happens. So this is the magnetism part for grade 10. We'll continue with this in grade 11 when we look at Faraday's law, and we'll also continue with this in grade 12 when we look at generators and motors. We're going to be applying magnetism. So this is just the initial part for grade 10. Any questions so far? Yes? Right? If there are no questions, then I'm going to give you an activity for you to do. There's a multiple choice for you to do, right? Then there's free response questions that you must do, right? So please do that. I think you need to do it before Friday, right? Because I'll give you another one on Friday. It's out of 34 marks, right? If there are no questions, I just wanted us to look at the consolidation exercise 10, just to revise. The consolidation on particles of which substances are made and their physical and chemical change. Those who have sent it in, I'll try and mark, but time sometimes is a problem, so please don't be angry with me. I'll try and do that. Right, so we start with the first one, 1.1. 1.1, which one of the following statements is incorrect about the properties of a physical change? Are you there? Are you fine, guys? Must I continue?
Yes, sir.
Okay.
Continue,
Yes, sir.
Okay, it says, which one of the following statements is incorrect about the properties of a physical change? The first one, when a physical change occurs, the compounds may rearrange themselves, but the bonds in between the bonds will not break. That's correct. So we're looking for the wrong answer. Physical changes in matter is reversible. Yes, we can reverse that. Right? Physical changes are reversible. Energy is absorbed when matter changes from solid to liquid. For example, you've got ice, you want it to be a liquid, you have to add heat for it to melt. So that one is true. Molecules are not conserved during a physical change. This is the incorrect one. Molecules are conserved, they remain the same. Mass is conserved, molecules is conserved, and the number of atoms is also conserved for physical change. It's only in a chemical change where molecules are not conserved because of the rearrangement. Right, so the correct answer here is D. That's the wrong answer according to the question here. Which one is the incorrect? So the incorrect one is D. Clear? Right, we move on to the
Yes,
next
sir.
one. In the compound water, H2O, the ratio of the mass is highlighted, it's written in bold here. So when you do the ratio, you're not doing according to hydrogens and number of hydrogens and oxygen, right? You're doing according to the mass of hydrogen to oxygen. So the correct answer is C. How do we come up with C? If you just look at hydrogen and oxygen, it's going to be 2:1. We are not looking at the number of atoms. We are looking at the mass. Hydrogen is 1 and there are 2. So you're going to have 2 grams. And oxygen is 16. So it's going to be 2 grams is to 16 grams. That's the ratio. And you simplify your ratio. You divide both sides by 2. So you're going to have 1:8 as your answer. Clear? That's a
Yes,
tricky
sir.
one because people can use 2:1, but we need mass. So please watch out for the clues in these questions here, especially words that are written in bold like this, or that are written in capital letter. That gives you a clue of what you're supposed to do. Right, we go to 1.3. The unbalanced equation for the chemical reaction is shown below. You've got methane, CH4, plus oxygen to give you carbon dioxide plus water. Which one of the following represents the coefficients of reactants and products in the balanced equation? All right. I'm going to have a challenge trying to write here. Let me see if I can write here. No, it's not working. Okay. Okay. Let me see. No. Okay. Let's look at this one. You've got CH4. You've got your CH4. Carbon here is 1. Right? And carbon here is also 1. Right? So carbon is balanced. Then you look at hydrogen. Hydrogen, you've got 4. And this side, you've got 2. So hydrogens are not balanced. So what do you need to do? You need to put a 2 in front of the water. Coefficient for water, you put a 2. If you put 2 here, what are you going to have here? You're going to have hydrogens will be 4. So 4 hydrogens on the left, 4 hydrogens on the right. Then by putting 2 on the water, it means your oxygen on the water is affected. So you're going to have 2. So oxygen, it means you're going to have 2 on the water and 2 on the carbon dioxide, which makes it 4. So here to balance, you need to put a 2 here. So methane does not change, it stays as 1. And oxygen becomes 2. So it's 1, 2. And here it doesn't change, so it becomes 1. And the water becomes 2. So your answer is 1, 2, 1, 2. So 1, 2, 1, 2 is C. That's how you balance that one. Is that clear?
Yes, sir.
Okay, next one, 1.4. A covalent bond forms between metal and non-metal atoms. That's wrong. A covalent bond is between non-metals only. Right, so that one is out. Next one, through electron transfer. In a covalent bond, there is no transfer of electrons, so B is out. Sharing of electrons, that's correct. In a covalent bond, electrons are shared between atoms, so that's the correct one. between positive and negative ions, that's ionic bonding. So this one is out. Right, we go to 1.5. Consider the unbalanced chemical equation below. You've got P4 plus hydrogen to give you pH3. Which one of the set of coefficients will balance the chemical equation? So let's balance. Phosphorus here is 4 on the left. On the right, it's 1. So how do you balance? You put a coefficient 4 here to balance. So you're going to have 4, and here you'll have 4. But by putting 4 here, you are disturbing the hydrogen. So it's going to be 4 by 3, which is 12 hydrogens. So how do you make 12 hydrogens on the left? You have to put a 6 here. So it's going to be 1, 6, 4. 1, 6, 4. So the correct answer is B. Clear? Right, then we go to the last one, multiple choice. During the formation of an ionic bond, the electrons are ionic bond, right? In an ionic bond, there is a transfer of electrons. So there's no sharing. So A and B are out. You are left with a transfer of electrons. So the answer is between C and D. Electrons must be transferred in an ionic bond. But from which element to which element? We know metals lose, so they give non-metals. So it must be a transfer from metals to non-metals, not from non-metals to metals. It should be from metals to non-metals. So the correct answer is C. Right, we move on to the next one. The next one, it says, consider the balanced equation below. You've got 2C8H18 plus 25O2, right, to give you 16 carbon dioxide plus 18 H2O. Right, 2.1, how many carbon atoms are on each side of the equation? So let's count them. Carbon here, there's 2, and here there's C8. So you multiply 2 by 8 to give you 16. Let's check on the right-hand side. Right-hand side, you've got 16C. So it means carbons are also 16. So the answer is 16. 1 mark for that. 2.2, how many oxygen atoms are on the right-hand side of the equation? On the right-hand side of the equation. So we are looking at this. We're not looking on the left-hand side. So here you've got, there's oxygen on the carbon dioxide, there's oxygen on the H2O. So we need to add the 2. So we're gonna say 16 times 2, which is 32, plus 18 times 1. So 32 plus 18 gives you 50. So your answer is 50 oxygen atoms. I gave 2 marks for this one. Right, then next one, 2.3. How many molecules are there on each side of the equation? Each side. So let's start here. We have got C8H18. That's 1 molecule, right? But there's a 2 there. So that 2 is multiplying. So there are 2 C8H18. And oxygen, O2 is 1 molecule. It exists as a diatomic molecule. So that's 1 O2. But the coefficient is telling us they are 25. So it's going to be 25 plus 2 for the left-hand side. We're going to have 27 molecules. On the left-hand side, let's check. You've got carbon dioxide, that's 1 molecule. There's a 16, so it's 16 times 1 CO2. So it's 16 plus 18, which gives you 34 molecules. So on the left, there's 27, and on the right, there's 34 molecules. So molecules are not conserved here. So this should be a chemical change. Right, then we go to next one, question number 3. We've got 5 minutes left. We have got which of the following reactions are synthesis reactions and which one are decomposition reactions? So we've got 2H2O. We're starting with 1 and we're making 2. So that's a breaking, that's a decomposition. The substance is breaking into 2. We start with 1 to 2, that's a decomposition. So you look at the reactants and product. Start with 1, break it, disintegrate into 2. So that's decomposition. We look at the second one, starting with 1, breaks into 2. NH3 and nitric acid, that's a decomposition reaction. Here we start with 2 and we make 1. So this is synthesizing. So it's a synthesis reaction C, 3C. Then you go to 3D, you've got Mg, magnesium plus oxygen to give you magnesium oxide. Starting with 2 molecules or 2 substances to form 1, so that becomes a synthesis 1. Right, then we move on. Number 4, write down a balanced reaction equation for the reaction represented by the following colored circles. So you've got this yellow is sulfur, the red is oxygen. So here it becomes SO2. Plus you've got oxygen, 2 oxygen, that's O2. To give you the yellow one is sulfur and you've got 3 oxygen, so it becomes SO3. So when you balance, you're going to have your SO2 plus O2 to give you SO3. You check here, sulfur is 1. This side is also 1. Then your oxygen, this one is not balanced here. There's something missing here. Your sulfur here is 1. Sulfur here is 1. Just ignore these 2 for now. So you're going to have 1 sulfur. Oxygen here, we have got 2. And here we've got 2. So 2 plus 2 makes it 4. And here, by ignoring this, you only have 3. So what do? We're going to put a 2 here. When you put a 2 here, what are we going to have? We're going to have oxygen, it's a 2 times 3, which is 6. And sulfur is now 2. So what are we going to do on this side here? We're going to put a 2 on the SO2. Right? So it's going to be 2 SO2. So the sulfur is 2. This side is 2. And the oxygen, when you put a 2 here, it's going to be 2 times 2, which is 4 plus 2, which is makes it 6. And here 2 times 3 makes it 6. So there's a 2 missing here. I'll correct it before I post it later or after this session here. Right. So here there's a 2 and here there's a 2. That's how you balance that one for 3 marks. Then we go to number 5. We have got 2 minutes, 20 seconds. Let's just discuss. Guys, we meet again on Friday, same time. Is it fine?
Yes, sir.
Okay. Please just let others know, those who couldn't join us today.
Yes, sir.
Joshua, please, can you post it on the WhatsApp group? I'll try and send the emails again. Yeah.
Okay, sir.
Okay. Let's just finish up this one here, number 5. In that 1 minute that is left, we have the question first. The question says, study the physical and chemical processes below and answer the question that follow. You've got X, Y, and Z. Define the term physical change. All right, physical change, what did you say is a physical change?
A change in which new substances are formed.
No new substances are formed. Next one, write down the letter of the process that represents the following: a physical change. The answer there becomes X. X is a physical change. Next one, 5.2.2, decomposition reaction. We have to look for the one that starts with 1 and giving us 2. So the answer is Y.
Y.
The name of the physical change stated in 5.2.1, that's a sublimation. I think we spoke about this sometime. Right, state 2 properties of a reaction that indicate that a change has taken place. We spoke about this one as well. Then what does the symbol delta represent? It represents your heat, right? But the question here says for process Z. I remember already you raised something about this, but it's fine. You just answered the question. I think it doesn't affect the answer. Clear?
Yes, sir.
Right. I think our time is up. We're gonna be cut anytime now, guys. Let's meet again on Friday, where we'll finish up number 6 and 7 and 8. Is that fine?
Yes, sir.
All right. I'll send the handout for magnetism after this. Thank you guys for joining us, and please invite your friends.
Yes.